Crewton Ramone's awesome math. This is a quick, we're going to start introducing the concept of radicals and square roots and counting by square roots. So far we counted, if we changed this and made it a 2, then we'd have 2, this would be 8, this would be 18, and this would be 36. Now we're setting up, and it's already written in there. Each one of these would be 3. Now, if I have 3 in each one of these, right? Now I'm saying that this is no longer 1. This is worth how many?
2.
This is worth how many?
3.
Do you see it's a 3?
Yes.
So how much is this worth now?
3.
3. In other words, instead of me having 3 here, I'm just going to use this for my 3. So how much? Kimberly, how much is this worth? Max, how much is this worth?
3.
3. You see it's worth 3? Pono, how much is this worth?
3.
Okay. So now I'm going to go over here, and I have how many? 3. My 1 is 3. One of them is 3. Okay, so now, if I use this one, how much is that going to be?
12.
Very good. How did you get to 12? Count by 3. 3, 6, 9, 12. Very good. All right. So 3, 12. Wow, trying to videotape really slows things down. All right, now let's try this. Let's count. Oh, good, but let's count. Everybody. 3. Okay, stop. Let's do it together. 3. 18, 21, 24, 27. Can you see that's just 3? 9? Right? But it's exactly the same thing as 3 of those. Right? Okay. So now, oh man, we got the next one. How much is that going to be? 66. Somebody guess that? What do you think? 42. What do you think, Chaz?
39.
What do you think this would be if each one of these is 3? Estimate. What do you think? Just guess. You can't be wrong. Just give me a shot. What do you think? We have one for, what did you say, 66? Okay, what do you think it is?
42.
42? That's a good guess. What do you think it is?
I thought it was, yep.
All right, let's count. Let's count and find out. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. All right, we're at 30. 33, 36, 39, 42, 40. What's 42 and 3 more? 45. 48. 48. Victory dances going on out there. 48. That's 316. Okay, well, in fact, we could do it. Let's do it. Let's do it. 16, 16, and 16. What's 6 and 6 and 6?
18.
What's 6 and 6 and 6, right? 6, 12, 18. Can you count by 6s?
Yes.
Have you sung 6 songs before?
Yes.
18. Okay, 6, 12, 18. Watch me write my 18. 18. See that? 18. Okay, so there it is. Now, how many is that? 1, 2, 3, 4. 48. Easy. Right? Or we could have counted it by 3s. Okay, so now, why do we do all of that? So we could do this. If this is a square root, see that? And the whole thing is 1, what's the square root of 1? What's the square root of 1?
1.
Square root of 1 is 1. Now I said the whole thing was 2. What's the square root of 2?
1.
2 times 2.
Well, that's what I'm saying. What's the square root of 2? Have you got a calculator?
4.
Have you got a calculator?
4.
Okay.
Yes, we got a whole box of them.
Alright. Do you have a calculator that has a square root key on it?
No.
Let's see.
Yes, we do.
Yes, because all calculators, almost every calculator has a square root key. Why is that? Because square roots are very, very, very important. Okay. So now I'm going to say, there is my square root of 2. How much is it? If the whole thing is 2, I want to know the sides. What would it have to be? Somebody said 2. Well, 2 times 2 is 4. It can't be 1 because 1 times 1 is 1.
What, look at this.
I'm asking for the square root of 2. This is the only time in math where I'll agree with you if you said, that's kind of hard. Because it is kind of hard. It is going to be square root of 2, square root of 2. As if you've already had the lesson, that's why. But what we're going to do is we're just going to say that if I have, let's say if I have this, and I have 9. Well, what's the square root of 9 again? Kimberly, what's the square root of 9 again? Good. Right? That's 3, that's 3. All the sides are 3, right? Okay. Could I say, I'm going to replace a couple of these. Could I say that that's the same thing as the square root of 9? One side is the square root of 9?
Yeah.
Right? Yeah. And could I say that square root of 9 times square root of 9 is what?
9.
9. What if I change this into 16? What's the square root of 16 again?
4.
What's the square root of 16?
4.
Jake, what's the square root of 16? Take 16 and turn it into a square. What's one side?
4.
I know. We're waiting for Jake, though. Okay. Look up here. What's it say? What's the square root of 16? Just look into the blocks. Come up here and come up here. Be quick. All right. Point to which one is 16. All right. Which one? What's one side of that square?
4. Wait. 4.
Why weren't you sure? Okay, go sit down. 4. You're right. It's 4. Okay. So could I say that that side is square root of 16? Is it 4 and square root of 16 the same thing?
Yes.
Is there any difference between square root of 16 and 4? It's the same thing. They're equal. They are equivalent. This is the same as that. Even though we don't write them the same, it's still the same number. Do you see that, Max? Do you see that? Okay. Now, so I'm going to say square root of 16 squared. So now, what am I going to say over here? Since doing the square root of 2, go ahead, do me a favor. Punch 2 and punch square root. Just put 2 and then hit square root key. What do you get? Should be 1.141. You tell me. Wait a minute. What is it? 1.41. I'm dyslexic. 1.41. Where'd it go? There it is. 1.41. 42. 1, 3. All right, and it goes on forever. That's a radical. Goes on forever and ever. So you know what? You know what's the easy thing to do? We just call it square root of 2. Square root of 2. Right? Okay. So if I have this thing right here, and I'm doing this, and I want to know what the sides are. Look over here. Do you see square root of 9? Square root of 9. So what would this have to be if I wanted to make it square and these two sides are going to be the same? Chaz, what would it have to be? If this is, see, I don't know what you were doing. If this is going to be 2, what's one side have to be to make it 2? 2 times 2 is 4. All right. Levi, what would it have to be? To make this 2. What would I have to make it? What would it have to be? Okay, let's do it again. Over here, this is, what is this? Square root of 9 times square root of 9 gives me what? 9. Square root of 16 times square root of 16 gives me what? 16. What if I had 25? Square root of 25 times square root of 25 would give me what? We'll give you 25. So what do I need over here to make 2? Square root of 2, square root of 2. Very good. Square root of 2 times square root of 2. Chaz, you see it? All right. Let's get crazy. Let's get crazy. Let's get even crazier. What would it have to be if it was 3? Right? Too easy, right? So, but wait, tell me, what does it have to be? What is the actual, say it, the whole thing? Square root of 3, square root of 3. And if I multiply those two together, I would get 3. All right, so why do we do all of that? So now I can talk about writing these out in radical form, just for fun. Okay, so now I say I have, we'll do this one first. I have square root of 12. Can you see that? Okay, stay with me here and pay attention. Look up here. You. Pay attention. Look. I have square root of 12. Can you see that I'm just going to count one side? Is that what we do every single time?
Yes.
Yeah.
Isn't it what we do every single time? When we count square roots, it just means, what does that symbol mean?
Square root.
I know, but what does that symbol mean when I do square root? What side do I count? Do I count all sides? Do I count 2 sides?
One side.
I just count one side. All right, so let's count one side. What would that be? If this whole thing is a 3, and we just a second ago I said, if I have the whole thing as 3, and one side is the square root of 3, and one side is the square root of 3, well then, isn't that a square root of 3?
Yeah.
How many square roots of 3 there?
4.
How many square roots of 3 there? If you can count the 4 there, I'll give you $10 million. How many square roots of 3 there?
2.
Wait. How many do you see?
2.
Anybody see more than 2?
Nope.
Anybody see 3? Shan. How many there?
3.
How many there?
2.
2 square root. You only count one side. 2 square roots of 3. That's all we did. 2 square roots of 3. Levi, you see it? Do you see 4 there? All right. Let's do square root of 27. I know what you thought. All right. Let's do square root of 27. Uh-oh. Oh, dear. All right. Square root 27. How many square roots of 3? 3. 1, 2, 3. I could count this side too. 1, 2, 3. Whatever side I want to count. Right? So what do I have? I have 3 square roots of 3. You see it? Now look over here. Just for fun. What if this was 8 and this was a square root of 8? Now, what would each one of these squares have to be? What would each one of these squares have to be? 2, you see it? So then how many square roots of 2 would I have? If each one of these was 2. Let's change this and make sure you can see what's going on there. 2, 2, 2, 2. All right, so how many do I have? How many do I have?
4.
If you can count the 4 there, I'll give you $10 million. How many?
4.
Is that one side?
2.
How many? Raise your hand if you think it's 2. Uh-oh, so now nobody's going to raise their hand if they think it's 4. All right, so we can count. All right, 1, 2. 2 square roots of 2. Well, because everybody can see it's just 2. Can you see that? I'm just saying that square root of 8 is the same thing as 2 square roots of 2. Is there anything hard about this? No. Not really. Like I said, I wish I could turn the camera around and show the expressions. All right. Now we got to play blocks. You get the idea. Let's build some pyramids and let's fool around, right? How many times have we built pyramids already? I think we've only built once, right? One time? Well, we haven't built pyramids before, have we?
Yeah, we did.
Have we?
Yeah.
Okay. We built, well, I mean, we built pyramids that were like 9s. We built pyramids out of 9s and 10s. But we did actual pyramids out of squares? I don't think we have.
No.
All right, let's do it today. Okay, let's get blocks and have fun. All right, maybe we did 1. Yeah. Okay. Crewton Ramone's House of Math. Now we break down and start playing.